Hello students, week 13, physics, grade 10, chapter 24, lesson 1, absolute zero, textbook page 469. At the end of the lesson, you will be able to describe what happens to the temperature of a substance when the thermal motion of the atoms approaches zero. As thermal motion of atoms increases, temperature increases. So you learned already, when the heat increases, temperature also increases. There seems to be no upper limit of temperature, but there is a definite limit at the other end of the temperature scale. If we continually decrease the thermal motion of atoms in a substance, the temperature will drop. So what is absolute zero? Absolute zero is the temperature at which no more energy can be extracted from a substance. So what is the point here? Higher temperature has no limit, but there is a definite low temperature, and that is called absolute zero. At absolute zero, no further lowering of its temperature is possible. It means absolute zero is the lowest possible temperature. This temperature is 273 degrees below zero, or you can say minus 273 degrees Celsius. Absolute zero corresponds to 0 degrees on the Kelvin or thermodynamic scale and is written 0 K, means 0 Kelvin. Okay, you learned already about Celsius scale and Fahrenheit scale, and you know that in Celsius scale and Fahrenheit scales you have seen negative temperatures, but in Kelvin scale there is no negative temperature. 0 is the lowest. So degrees on the Kelvin scale are the same size as those on the Celsius scale. Means, for example, ice melts at 0 degrees Celsius or 273 Kelvin. Water boils at 100 degrees Celsius or 373 Kelvin. So you can see the difference. They are in the same size. Look at this figure. You can see difference in temperatures of different substances, or you can say in different objects. At bottom you can see 0 Kelvin, that is minus 273 degrees Celsius. Actually helium boils at minus 273 degrees Celsius. 0 Kelvin is little bit lower than that, that is exactly minus 273.15. Then you can see oxygen boils 100 Kelvin, dry ice vaporizes 200 Kelvin, then there is 273 Kelvin. You can see ammonia boils, so it increases. As you can see, water boils, tin melts, iron melts. Then here you can see about carbon arc lamps. Then here 6000 Kelvin, surface of the sun. Then when you go on top, you can see 20,000 Kelvin, that is plasma. Plasma is the fourth state of matter. It is in high temperature. And then above that, surface of a hot star, 50,000 Kelvin. And then you can see center of the sun and also hydrogen bomb. When it goes to hydrogen bomb, you can see 100 million Kelvin. So that is the highest temperature, but this is also not a definite one. Higher temperature has no limit, but lower temperature, as we see here, minus 273 degrees Celsius, or exactly you can say minus 273.15, that is 0 Kelvin. Okay, can you answer this question? A sample of hydrogen gas has a temperature of 0 degrees Celsius. If the gas is heated until its molecules have doubled their average kinetic energy, means the gas has twice the absolute temperature, what will be its temperature in degrees Celsius? Okay, the answer is, at 0 degrees Celsius the gas has an absolute temperature of 273 Kelvin. twice as much average kinetic energy means it has twice the absolute temperature. This would be 546 Kelvin or 273 degrees Celsius. Okay, at the end there is a concept check question. What happens to a substance temperature as the motion of its atoms approaches zero? Try to find the answer, and thank you. See you next time.